this. When you just quickly glance down at the type 2 questions that you see on your sheet, like sine theta is equal to 0.5879, cos theta is equal to negative 0.9563. What can you tell me is the difference between these types of questions and the type 1 type of questions that we did? There's definitely decimals, and the type 1 questions had what given to you already? The degree or the angle. So in the type 1 questions, I gave you the degree. I said sine 315, cos 500 and whatever, or 135. In the type 2 questions, this is when the ratio is going to be given to you as a decimal. I've made it very specific. And anytime you have a number after the word sine, cos, and tan, and it's given to you as a decimal, then you're going to be using this specific strategy and method. So just make sure you have your calculator, put it into degree modes, because you will need a calculator for type 2. All right, my recipe for success. There's a story behind why I call it that a couple of years ago. We'll talk about it after. The first thing you're going to do is you're going to change theta to beta in the question. If you have a reciprocal trig ratio, you're going to change it to a primary trig ratio. You're going to determine the angle by using the inverse, but if the ratio is negative, do not include that in the calculation. You're going to use the CAST rule to figure out which quadrant the related acute angle is in, and then you're going to place the related acute angle and solve for theta and theta 2. Sounds very complicated, but when we do our examples, it'll make sense. So I'm not even going to go through what the rules are. We'll do them as we do each question. Let's start with question number 1, which is sine theta is equal to 0.5879. I'm just going to rewrite this, 0.5879. Rules, the first step is change the theta into a beta. So I'm going to rewrite this. I'm going to say sine beta is equal to, and if the decimal given was a negative, I would rewrite it as a positive. But it's already a positive, so we don't need to worry about the sign. We're just going to write it as 0.5879. Can anyone think of a reason why, if the beta is there, you have to have a positive ratio? It's because we've always said beta has to be positive. That's why you always change it. You're going to use your calculator. You're going to go sine inverse, and you're going to put that decimal in, 0.5879. And it's going to give you an answer, which we can go ahead and just round to a whole number. So I'm getting beta to be equal to 36 degrees. Okay, now here's the thing. We know what the related acute angle is, but we don't know if we should draw it in quadrant 1, quadrant 2, quadrant 3, quadrant 4. I just want to remind you, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. Do you guys remember when we did all the CAST stuff? And you might want to make a note to yourself, it is for these type 2 type of questions where you're finally going to have to use CAST. So you don't have to write this down, but just look with me. Remember, CAST was C-A-S-T. And what it meant is everything is positive here, sine is positive here, tan is positive here, and cosine is positive here. So you're going to go back to the original question, sine theta is equal to positive 0.5879. And you're going to try to figure out where, in which quadrants is sine positive. So what do you think? What 2 quadrants is sine positive in? S and A. So it has to be in quadrant 1 and it has to be in quadrant 2. So just right beside this question, I'm going to write down Q1 and Q2 to let me know that quadrant 1 and quadrant 2 is where sine is positive. Okay. So now when we draw our angles, we actually have to draw them in 2 different quadrants, and we're actually going to end up with 2 different answers. So here's what you're going to do. You're going to go ahead and get a ruler, and you're going to draw one of them in quadrant 1. And then you're going to draw another terminal arm in quadrant 2. And another note you can make to yourself is type 2 questions are always going to have 2 different answers. Okay, we need to put in our betas. So think back to the little bow tie structure. And you hopefully should remember that our betas are drawn inside. So I'm going to go ahead and put a beta in here, and I'm going to put a beta in there. That's my related acute angle measurement. Okay, how are we going to figure out the two thetas? So the very first theta is going to be from the initial arm to the very first terminal arm, and it's going to look like this. And I'm just going to label that 1. I need to draw all of these a little bit closer. So this is our beta. This is our theta 1. And the second angle, which is our theta 2, is going to be drawn from, sorry, let me just get yellow. It's to color code it somehow. There we go. It's going to be drawn from the initial arm all the way to the other terminal arm. So swings all the way around. Of course, I'm not going to be happy with that. So I'm going to do it one more time. And then I'm going to label this, and it doesn't matter where you label it. You can label it anywhere, and you're going to call this theta 2. Okay, now for the last step, the question says determine all possible angle measurements between 0 degrees and 360 degrees to the nearest degree, include a sketch. So now what we have to do is we have to actually figure out what theta 1 and theta 2 actually stand for. So theta 1, how do we figure out what the measurement of theta 1 is in quadrant 1? You know what? Yeah, in quadrant 1, the measurement of theta 1 is the same as beta. And we decided beta was 36 degrees. So theta 1 is going to be equal to 36 degrees. And then for theta 2, if we know beta is 36 degrees, what is the calculation to figure out what theta 2 is? 180 minus, good. So it's going to be 180 degrees minus 36 degrees. And like I said, I always say you can use logic for this, or you can just memorize the formulas that we had, or the little equations that we had in that very first day. And that's it. That's the whole question. All right, step number 1 is we need to change the theta to a beta. And step number 2 is if we have a negative in our ratio, we need to change it to a positive. So I'm going to rewrite this as cos beta is equal to positive 0.9563. The number, everything still stays the same. You literally just change the negative to a positive. Now you're going to use your calculator and you're going to go cos inverse 0.9563, not including the negative because beta cannot have a negative ratio. And we said we're going to round everything to just a whole number. And I end up getting 17 degrees. Now for the next part, we have to use our cast rule. So remember quadrant 1, quadrant 2, quadrant 3, and quadrant 4, CAST. In order to figure out which quadrant you're drawing it in, you have to go back to the original question, not the beta, but the original question that was given to you. In the original question, cosine is negative. So you have to figure out in which one of these quadrants is cosine negative. Everything is positive in quadrant 1, and cosine is positive in quadrant 4. So which quadrants is cosine negative? 2 and 3. Good. So at the top, right beside the question, I just write down quadrant 2 and quadrant 3. That's where we're going to be drawing our angles. So remember when I said cast, oh, we're going to get to it, we're going to get to it. This is what I meant. this was the whole, maybe I should have done it and waited for this. Done it in order. I don't know. Now you know it, right? So go ahead and draw your angles or your terminal arms in quadrant 2 and quadrant 3. And then you're gonna remember the little bow tie structure, which like looks like this, and that means our related acute angles are always in the inside. So we're gonna label our related acute angle over here and over here. Do we know what the related acute angle is? It's 17 degrees, right? We don't need to write that down. If you wanted to, you could, but I just leave it on the outside. Now we're gonna go ahead and draw our two thetas. So our first theta starts from the initial arm and goes all the way around to the first terminal arm. And you're gonna label that theta 1. And then the second angle is gonna be from the initial arm all the way to the other. Oh, all right, I just lost everything. How did that happen? I think I pressed stop share, sorry. Okay, so it's gonna be from, and then I'm gonna call this theta 2. How do we figure out theta 1? We kind of did this in the last step. You're gonna take 180 degrees and you're gonna subtract beta from it. So it's gonna be 180 degrees minus 17, and that's gonna be, oh, I can figure that out without the count, 163 degrees for theta 1. How are we gonna figure out theta 2? Good. It's going to be theta 2 is going to be 180 degrees plus 17. Because you're going 180, then you're adding a little bit more of the beta. And so theta 2 is going to be 197 degrees. We'll do C together. I'll let you do D by yourself, and then we'll do E together. Because anytime there's a reciprocal ratio, it's done a little bit differently. Does this make sense, you guys? Are we okay with this? Oh, and I used it again. Oh, my bad. I'll remember next time. But now I have a color theme, and I don't know if I can give that up. Dang it. Just for you. Fine. All right, on to question C. Question C is cotangent theta is equal to positive 2.7475. Okay, so now we have to do three things. We have to change a theta to a beta. If the ratio was negative, we would have to change it to a positive, which we don't have to do here. And we have to change the reciprocal, we have to change the secondary trig ratio to a primary trig ratio. And I like to do that all in one step. So here's how I'm going to do it. I am going to first write it as tan beta. So I changed the cotangent to tangent. I changed the theta to a beta. Luckily, 2.7475 is already positive, but I need to flip this ratio around and write it as 1 over 2.7475. And since you've all studied for your quiz, you all know we have to do this. Okay, good. We're going to go ahead and do tan inverse of 1 divided by 2.7475. And we'll just round this to the whole number, which is going to be 20 degrees. Okay, so CAST, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. According to the original question, you can think of cotangent as tangent. So in which one of the quadrants is tangent positive? T and A, which means quadrant 1 and quadrant 3. So, yep, both of them. So we're going to go ahead and draw our angles in Q1 and Q3. Drawing this one is easy for me because I can just do that. Draw yourself a little bow tie and figure out where your related acute angles should go. One is going to go right here, and the other one is going to go right there. Theta 1 is going to be like so. Okay, can I find another color that's not yellow that I like? And then theta 2 is going to go. Have we done anything in the third quadrant yet? Oh, the last question. Yes. And then this is going to be theta 2. We've actually done one now in quadrant 1, 2, and 3. So hopefully now you guys are, it's making more sense. In quadrant 1, theta is the same as beta. So theta 1 is just going to be equal to 20 degrees. And in quadrant 3, to figure out theta 2, what do we have to do? 180 plus 20. And so theta 2 is just equal to 200 degrees. I'm not going to lie, it doesn't look as good without the yellow. It doesn't. You can? It's like look, the yellow is just added, like, it was like summery, you know? Taya? Oh, the yellow matched Taya's sweater. All right, so we're doing question D, which is tan theta is equal to negative 3.5234. We first change, it's already a primary ratio, so we just have to change the theta to a beta and make this positive 3.5234. We're going to do tan inverse 3.5234, and we get 74 degrees. CAST, which means quadrants 2 and 4 are going to have tan. Which quadrant are you guys drawing question D in? So CAST, if tan is negative, it has to be in these two quadrants, 2 and 4. Remember, you always look at the original question. So tan is negative. That means tan is positive here and here. It's negative here and here. So quadrant 2 and quadrant 4. Okay, so we're going to go ahead and draw our line going through this. Also, this is our first time drawing it in the 4th quadrant, so that's exciting. Something to look forward to. And then theta 1 is this way. And then theta 2 is going to be a mission for me because it's going to go all the way around. So it's going to be, oh, not bad. And then this is theta 2. So theta 1 is going to be equal to, Taya, tell me when you get to this part, I'll do the theta. Exactly. All right, so theta 1 is just going to be 180 minus 74, which is just going to be 106 degrees. And then theta 2 is going to be 360 minus 74, which is going to be 286 degrees. All right, you guys, this is what I got for question D. I got beta to be 74 degrees. I drew it in quadrants 2 and 4. I labeled my betas. I labeled theta 1 and theta 2. I got theta 1 to be 106. You guys get that as well? And then I got theta 2 to be 286. Did you guys get that as well? Yes, confirmation? Yeah. Yay, I see nods. All right, let's do question E together because it's another reciprocal ratio. I think the hardest combination was if I gave you a reciprocal ratio with a negative ratio, because then you have to do a lot of changes, but I didn't give one as an example for this. All right, last example, question E. So secant theta is equal to 1.7867. What is the related primary ratio to secant? Good. So I'm going to go cos beta, and then I have to take 1.7867. If it was negative, I change it to positive, and I have to take the reciprocal of it. So it's going to be 1 over 1.7867. I'm going to go cos inverse 1 divided by 1.7867, and I'm going to get 56 degrees. Okay, I'm going to figure out where I'm drawing this. So CAST, according to the original question, secant is like cosine. So we're trying to figure out where is cosine positive. Everything is positive here, and cosine is positive here. It would be negative here and here. So this is quadrant 1, and this is quadrant 4. We're going to be drawing it in quadrant 1 and 4. Okay, so I think you're going to learn to really like when things are in quadrant 1 because there's not a lot of work. Okay, and there it is in quadrant 4. I'm just going to erase this a little bit, and I'm going to erase this a little bit. Okay. And then my beta is going to go here and here. Theta 1 is going to be drawn like this. And then theta 2 is going to be drawn like this. So what'd you guys get for theta 1? Same as beta, 56 degrees. Taya, not to put you on the spot, but do you want to do the calculation for theta 2? What'd you do for that? Yay. Yeah. Which is going to be 304 degrees. That wasn't too bad, right? Make sense? You guys, the textbook questions are what you're going to be doing. I will show those to you guys at home. Oh, yes, it's no homework day. Well, you can do them on the long weekend then. There is the textbook work for you guys.